somewhere. So I'll do that off to the side here. What that means is wherever you see an X,
Mhm.
and this right here, you're going to replace it with X plus H. Okay.
Mhm.
And then you do have to simplify. So what that means is you will be foiling, which is probably the most difficult part
Mhm.
because it's just letters, but this
Yeah.
is something you can do. X times X is X squared.
Mhm.
X times H is XH. H times X is XH. H times H is H squared. And you're multiplying all of that by 5.
Got it.
Okay. So what some students will remember is they just say, I'm going to memorize that it's X squared plus 2XH plus H squared.
Mhm.
And then you don't have to think about the foiling. You do have to distribute that 5 to everything. 5x squared plus 10xh plus 5h squared minus 7. That is now, I'm going to go back to the highlighter. That is the f of x plus h.
Mhm.
So you're going to take everything you just wrote, 5x squared plus 10xh plus 5h squared minus 7, and you're subtracting f of x, which is the 5x squared minus 7 in parentheses.
Okay.
And that's all over h. It gets worse before it gets better,
Mhm.
but it will here in a moment.
Mhm.
All right, so you're going to distribute this negative that's in front of the parentheses to both here.
Mhm.
So that becomes negative 5x squared plus 7. And then you're just bringing down the rest of the stuff. And then finally, you'll have some cancellations.
Okay.
So basically everything cancels that doesn't have an H in it.
Mhm.
And you're left with 10xh plus 5h squared all over h.
Got it? Yeah.
And then you divide each of those by h.
Mhm.
It's not a choice, it's both get it. And then you cancel the h's. On the right, there's 2 h's up top, power of 2, so you just cross out the exponent.
Mhm.
It becomes 10x plus 5h.
Okay, got it. Yeah, those are definitely a lot of steps.
A lot to do here, yeah.
Mhm.
There is a pattern if you do enough of these, but I would still recommend working it out. Your
Mhm.
check is that everything that you have left over in the numerator has an h in it because it's going to divide by h.
H. Okay.
And basically everything in this f of x will cancel if you've done it right.
Got it.
All right, so whenever you're ready, if you want to share screens, I'll be happy to work through another one.
Okay. I only have like one type of this problem.
Oh, okay. It's up to
Yeah.
you. I can make one up or we can just move on, whatever you want.
I guess, yeah, then we can try another one if you could like come up with one.
It's up to you. Do you want to use the time for that? I'm just asking.
Yeah, I want to learn how to
Okay.
do one more. Just
Okay. All right. So let me I don't want to make it too difficult here. So I'll do f of x equals x squared plus 3. Let's do that. So you've got the hard thing here is coming up with x plus h. Actually, let me put a 2 in front. That's probably more realistic.
Okay.
So go ahead and calculate that, and I'll do it here in a moment. We'll compare results.
Okay. So I guess I get stuck on the first step with these because I have to create that first equation like with that formula.
Yes,
Yeah.
yes, you have to put x plus h in for x.
Okay.
So it's just a replacement.
Okay.
It's like when you buy something new, you take the old one away, put the new one in there, and sometimes you got to do a little rearranging or something.
And then here, this is where I foil.
Yes.
Yeah.
And I would recommend writing it out that way. Yeah, you don't make sort of some classic mistakes here.
Okay. And then every time you FOIL it, it's always gonna be the x squared plus 2xh plus h squared.
Yes.
Yeah.
And then you do have to distribute in.
Mhm. Okay, yeah, I got there. Okay, so yeah, I got to the last step, just like how you have on the screen, but yeah, that's, I'm like stuck.
Okay,
again.
so this is all good, but this is all kind of side work because what you're asked to do is f of x plus h minus f of x all over h.
Yeah.
So you have to take the work that you just did,
Mhm.
and that goes in the numerator there.
Okay.
See if we can do that. Yeah, and then you subtract f of x.
The original, like, yeah, equation.
Yes.
Yeah. Okay.
Yes.
And then 3 minus. And then here, this is where you can see like what you can simplify over
After you distribute the negative.
negative,
So
right?
do negative first, and then you're gonna have a chance here.
Mhm. So. Just cancel out and then. So now you have 4xh plus, or actually you want to put the, yeah, 2h squared over h.
Yes, and again, notice that everything that's left in the numerator has an h in it. It has to.
It has to, right?
It has to. It's a check.
Mhm.
I emphasize that a lot for calculus students. I don't think in
Mhm.
brief calculus you end up doing, you might, depends on the instructor, probably.
Mhm.
Then you cancel out the h's.
So you have 4x plus 2h.
Yes.
Yep. Okay. Okay, that makes a little bit more sense now. Yeah.
Probably good for you to practice one or the other again on your own,
Mhm.
maybe tomorrow,
Yeah.
just to see if it's still clear. But
Yeah. Yeah,
if
this
you
was
wanna,
helpful. Yeah.
great. So whenever you're ready, if you want to share your screen again, we can look at some more
Mm-hmm.
questions.
Okay. Okay. Same with this one. I'm still a little confused on these.
Okay.
Can you see my screen? Yeah.
Yes, I just grabbed a snip and I'm going to share
Mhm.
here momentarily. All right, there we go. Okay, so the bubble, I look at these, this is a bubble down here. The bubble means composition.
Mhm.
And it's better written as h parentheses h of x like this.
Mhm.
And the bottom one is f parentheses f of x. So let's look at the first one here. I'm going to rewrite h of x, x squared plus 8.
Mhm.
And then I'm going to write x squared plus 8 over here. So we're taking x squared plus 8 and putting it in for
X. Okay.
yes. So the way that looks, and you don't need to worry about notation, but it's parentheses x squared plus 8 squared
Plus 8.
plus 8.
Mhm.
And just like the previous problem, you do have to FOIL.
Mhm.
So you have to write out x squared plus 8, x squared plus 8 plus 8.
Mhm. Yeah. Okay. And then,
So go ahead and try FOILing that. I'll
yeah. So would that be x to the fourth plus 16 x to the fourth?
Squared.
Yeah, you can't. Oh, yeah, you can't. Okay. To square 16x to the power 2 plus 72.
Yes,
Okay, got it.
that's your first box.
Got it. Okay.
Okay. The other one, we're gonna do the same thing. It's a little more awkward. I write them twice when they're the same one. So you take all of this and that goes in for X.
For x, okay.
So it's more about how you write this. So big parentheses here for 5x like that.
Yeah.
And if you've got that, your focus will now be on the bottom. The bottom's really 5/1. You can pre-reduce, or you can multiply the top, multiply the bottoms, and then divide. How do you see it? Do you see it as multiplying 5 and 4, or do you see it as
Yeah, I just did 20 over 5x.
20 over 5x? Good. Your focus should still be on the bottom now. 5 goes into 20, so it's 4 over x. And from here you multiply by the reciprocal.
Yeah.
And this is where you might need to rewrite the top as being over 1. Some cancellations, you get x over 1 or x.
Okay, so it's just x is the.
Yes.
Or, yeah. Okay, got it. Okay, I'll share my screen again. Okay, I guess I need some more clarification on this one.
Sure, yeah, no problem. Let me just grab a snip. There's a bubble again, okay. All right, share my screen. Okay, so again, bubble means g of h of x. So they're not different. They're not the same this time, but start with well, you take the inner one, which is h of x, and that's what's going to go in for x.
For x, right?
But it happens to go in 2 places. So it's 4x plus 1 minus 2 over 4x plus 1 minus 5.
Yeah.
So that's 4x minus 1, 4x minus 4, like that.
Yeah.
All right. Now, so that's everything for the first one. The domain of this of the result here, you should start by looking at the innermost one, the h of x, and seeing if there's any restrictions.
Okay, restrictions.
And this is a line, there's no restrictions. Remember, restrictions are like dividing by 0 or square roots of negative numbers.
Okay, yeah.
Okay, so that's something to consider. So there's no restrictions there. So then you move to the new one here and you look for restrictions here. So your restrictions are, well, you cannot divide by 0. So we need to figure out where the denominator is equal to 0. And that's when 4x equals 4 or x equals 1. So this is your restricted point. It's actually everything but 1.
Everything but 1. Okay. And then I have to write that in interval.
Yes, interval. So let me I like to go to a number line to kind of show that it's minus infinity to infinity, but at 1, it's excluded. So it's everything but that. That gives you the 2 intervals, minus infinity to 1. It's parentheses because 1 is excluded and parentheses always go with infinity. Union 1 to infinity. It's kind of a complicated way of saying everything but 1, but that is in fact what it is asking for here.
Got it. Okay. Just plugging those in. Okay, and then. Okay, I'll share my screen again. I guess that takes me back to the beginning because like this is like review and I need clarification on like 2 different types of problems.
Sure.
So for these ones, when it's asking to find the domain, we're just looking to find the denominator on both of these.
Yeah, where the denominator equals 0. The g of x you have to factor, which can be a little bit more work, but that is in fact what it is.
This is where I set this equaling to 0.
Exactly.
And then this I would have to factor.
Yes.
Okay.
Do you want me to share that?
I think I can work on it. Yeah. I just wanted to get clarification on that. And then I think this one is also like similar because it says find the domain of the function. So would it just be the denominator here again?
There's also the numerator to consider because it's the square root. So you have to set the top part under the root. So the x plus 9 greater than or equal to 0. And then wherever the bottom is equal to 0 is excluded, but they both have to be true. So I think this would be a good one for me to grab to provide some more explanation on. It's kind of like you look at them each independently and then see where things work together. So we'll do that here together. All right, so for the first one here, you said x plus 9 greater than or equal to 0.
Okay. And how do you know when to set it greater than or equal to 0?
So the square root functions require that the part under the root to be greater than or equal to 0. They're only defined for 0 and positives.
Okay.
I didn't really answer it, but hopefully you know what to do. So this means that x is greater than or equal to -9. And that's where I'm going to draw kind of a first number line here. I'm just going to put -9 there. So it's everything to the right of that is good. Now we're going to look at the next one, 3x plus 2. Well, it can't be 0.
Okay.
So you solve that for x is -2/3. And that's what it cannot be. That's the excluded value.
So it cannot be because it's not greater than or equal to? Or
you're dividing by 0 when the bottom is 0. It's two different rules. It's like that's not gonna look right. So why did that delete? Sorry. So the bottom you set equal to 0 always. Well, okay, there could be a square root in the bottom, which we haven't seen here, but the square root requires it to be greater than or equal to 0.
Okay. So
the bottom, so what if you were just look at them independently, the bottom one is good everywhere except -2/3. Okay. The top one though starts at -9 and goes to the right, and they have to both be true. So we're looking for where they're both true.
Okay.
So it's basically like, where is the overlap between them? So the overlap is everything except for that -2/3. So sometimes you make kind of a third graph to show the overlap, but I think you can see it there. So you start at -9 and you go to -2/3 and everything is okay there. But then you have to skip -2/3 and go to infinity.
Oh, I got it. Okay, that makes more sense with the number line. Okay, I'll share my screen again. See what else I can work on. Yeah, okay. Yeah, so for this one, we're finding all the values of x that are not in the domain of h. So would this mean like restrictions?
Yes, exactly. Yeah, exactly. It's wherever the bottom equals 0.
So I just have to FOIL this equation and then
Factor the bottom,
factor
yeah.
it. And then the two answers are the two like restricted values, like the x's.
Yes, just a slight clarification though. This one only has one when you factor it.
Oh,
Believe it
yeah.
or not, they're the same. It's a
Yeah.
perfect square trinomial. So it could be that there's just one.
Mhm. Okay, okay. Okay, I want to see what else was I talking about. 14. Yeah, I like did not remember this at all.
All right, let me grab it.
Problems, yeah.
All right, it says, let's let that load up. 1, 2, 3, go. There it is.
Mhm.
Melissa is a software saleswoman. Let Y represent her total pay in dollars. Let X represent the number of copies of English as fun she sells. Suppose that X and Y are related by the equation 90X, Y equals 90X plus 1800. Answer the questions below. Okay. What is the change in Melissa's total pay for each copy of English as fun she sells? What is Melissa's total pay if she doesn't sell any copies? So one of these problems is asking for the slope, and one is asking for the y-intercept.
Okay.
The slope is always the rate of change, and it's something per something. Okay.
Yeah.
So notice the word change there.
Mhm.
That's the slope. The slope in this problem is 90.
Mhm.
The other number is the y-intercept. What that represents is when x is 0. So basically, what happens if you don't do anything? And if you put 0 in for x, 90 times 0 plus 1800 is just 1800.
100, yeah. Okay. Oh, okay, that's all it is. It's just like you're
Yes,
breaking up the
it's just
problem.
identifying, but it's easy to mix them up. And you
Yeah.
gotta look for keywords for slopes, rate of change over and over
Okay.
again.
Yeah, I thought I was like looking at it, I'm like, this looks easy, but I was like, am I solving for something? But it was just asking the components of the equation. Okay.
Yes, that's right.
Okay. Uh, okay, I'm gonna grab. I'm gonna wait. I want to clarify if I did this equation like correctly or solve this correctly.
All right, I'm gonna grab a snip here. All right, so on my side, what I'm gonna do here is look at oh, I see, it is an equation.
Yeah. So
Okay, I guess I do have to write an equation here to solve it. Okay, so x plus y is 55. Do you want to see the work, or do you want me just to work through it real quick?
work through it because I already solved for it. I just wanted to make sure that I set it up correctly.
Okay.
Yeah, so I have like x plus y equals 55, and then my other equation is 30x plus 20y equals 1500.
Yes, that's correct. So now I can check your numbers. 40 plus 15 is 55.
Yeah.
1200 plus 300. Yes, those are correct.
Okay, great. Okay. Okay, yeah, 23. I still get stuck on these. Like I don't know why.
Okay, so grab it here. All right, so it says, suppose that the function f is defined for all real numbers as follows. They want you to find f of -3, f of 1, and f of 5. So you look at the number inside parentheses, and you decide if it's 1. If it's 1, then you use this -3.
Okay.
But if it's not 1, you have to use the equation. So for -3, you just ask yourself, is -3 not 1? Yeah, it's not 1. So I'm going to use this equation.
Okay.
3/4 times -3 plus 2.
Mhm.
2 is really 8/4.
Mhm.
So x becomes minus 1/4.
4. Oh, okay.
Then you do the other one. 3/4 times 5 plus 2 is 15/4 plus 2. You can think of plus 2 as 8/4. 23/4.
Okay. So if the number like doesn't, because yeah, -3 does not equal 1. So that's when you always
Yes.
you look
Yes.
at the next.
Yeah, and there's a few other ways they can define the right side that we're not seeing here, but it's just a yes no. It's binary. Lights on, lights off. It either is 1 or it isn't.
Mhm. Okay. Mm. Okay, I'll share my screen again. Okay, so I know, like I attempted this one. So, because I know we've done like quite a few of these. So this one is like where we use the quadratic formula, but there's no C value. So does it matter if there isn't a C value, or am I doing something wrong?
Yeah, I mean, to use the quadratic formula, you're right that you do need the C value.
Yeah, so when I set this up, I just have it as it's 16t plus 40t equals 0, but there's no C. Or
Okay,
does it-
well, yeah, let me give you some, because there's a bit more here. Like I want to answer them one at a time, which is, you're right. To use the quadratic formula, you need C value. Now you actually do have it here. Let me though slightly rewrite this so that you can see how you do have that C value. It's minus 16t squared plus 40t plus 0.
Plus 0, yeah.
So the negative goes with that. So your A is minus 16, your B is 40, and your C is 0.
Mhm.
Okay, now there are 3 things that they could ask you for in a quadratic typically.
Mhm.
They can ask you about 1, 2, or 3. This one is asking about position 2.
To the maximum, yeah.
The quadratic formula is used at 3. The vertex formulas are used at 2. So the vertex formulas are needed here. Minus B over 2A.
Mhm. Okay.
So it's asking how long it will reach its maximum. That's that value there. Minus 40 over 2 times minus 16.
Mhm. Oh, okay. Wait, what? So that now that we have 40 over 32.
Yes, that's your answer. That you have to, it says do not round your answer. But you don't want to leave it as 40 over 32. Notice there's no fraction bar here.
Yeah.
So you have to actually go to the calculator and get the number here.
It doesn't, yeah.
1.2 maybe.
Yeah, yeah, it's 1.25, but
25, sorry.
oh yeah,
that does matter.
Okay.
Does matter. So
Okay.
that typically they're asking you about 2 and 3. Either they're asking about where the vertex occurs or like how high, or they're asking you when it comes back down to earth, when it hits the water, when it hits the ground.
So the quadratic formula, so say if they did give me, like say if it said like
when does it hit the ground?
When does it hit the ground? And then yeah, that's where I would have my like C value if it like gave me like a number, like a time.
You can if you can use this to find this 0.3, the quadratic formula, but it's not the right one to use here because C is 0.
You don't have a C. Okay.
What I think you're thinking of is like, let's say they ask you like, when does it reach a height of, I'll just say 20.
20, yeah.
That's when you have a C value. It's based on that because you're setting the whole equation equal to the height. and then you move it over to the other side of the equation,
Mhm.
and that's your C value.
Yeah, yeah. Okay, yeah, that's what I was thinking of. Okay. Let me find something else to work on. Um, okay, yeah, I just want to, okay, I'll share my screen. Yeah, I mean, I feel like this is like pretty easy, but this is where I would break up these like individually and set them equal to 0.
The ones you can factor for sure.
Mhm.
You don't necessarily.
Because say if you set negative 4x equal to 0, you would just have 0. Like,
Yes,
yeah.
yes, but and the x squared minus 16 does factor, but the
Okay.
one on the right does not.
It's not.
Do you want me to show this?
Yeah, I will, this would just be 4.
So,
And then,
so that's the classic mistake is you have to factor to get both. So, but you start out, totally spot on. Minus 4x equals 0,
mhm,
x squared minus 16 equals 0, x
mhm,
squared plus 36 equals 0. So the first one you divide by -4 and x equals 0.
yeah, mhm.
The next one is difference of squares.
Got
And
it.
if you don't remember that, that's fine, but you can't say that there's only one solution. There's always two in this
Yeah.
case. The one on the right has no solution,
Mhm.
and the difference is that plus, and you might wonder, why does that make a difference? It's because you cannot take the square root of
The negative.
negative and get
Right. So my zeros listed are -4, 0, and 4.
yeah,
Like if I were to like write it out.
0, 4, -4. Yes,
Mhm.
sorry, 0, 4,
Yeah.
and -4.
Because they like you to write it like based on like the timeline, right? Usually on Alex, that's why I listed it like that. 0, 4. Okay. Yeah, and I guess these ones are similar as well, because I feel like I mixed up this type of problem with that last problem. So when it's asking for like the multiple, how do you say this?
Multiplicity.
Multiplicity. So say like, because it's based off of the exponent.
That's right.
Yeah. So like zeros of 3, we're just looking at this.
Yeah. So does the order matter? Oh, I'm sorry. 0 is a multiplicity when I see how they're doing it.
Yeah.
So that is -5 and 2. -2, -5 and -2.
For this, because this is like an imaginary 1.
Yes.
Yeah.
Yes.
So be -2.
And
But there's none for 2 because we have
that's
nothing to the power of 2.
that's right.
And then this would just be 11.
Yes.
Okay. And then, yeah, I want to work on this one. I'm just gonna work through this review, please.
Okay. Okay, so it says write a quadratic function h whose zeros are 9 and 2. There's a relationship between a 0. So let's say x equals 9 is the 0.
Mhm.
The factor, which is what you need, is x minus 9. Now, if you're wondering how you get that, you subtract 9 from both sides and it becomes x minus 9 equals 0. Then that's your factor.
Mhm.
You do the same thing for your other 0 too. The
Mhm.
factor becomes x minus 2.
Mhm.
The reason is because you subtract it. Now, let's say there was another problem where the 0 was a -5.
Mhm.
You would write x equals -5, and the factor would be x plus 5.
It's like the opposites.
Yes. So now to write the function, you have to take the two factors and multiply them together.
Mhm.
X minus 9, x minus 2.
That's where we FOIL.
Yes. So x squared minus 2x minus 9x plus 18. combine the O and I.
Mhm. Okay, I got it. Let me see what else. Yeah. Okay, I'm switching over to like logs again. I know we had worked on one of these before with the
Yep.
domain range, but I'm like still a little rusty on these.
Okay. Yeah. Grab a snip here. Okay. The domain for an exponential function is always all real numbers. Sorry, I meant to be sharing there. Let me go to where I can share. The domain is always all real numbers, minus infinity to
positive infinity. Yeah.
yes. The range depends on the horizontal asymptote. So this -3 right here
Mhm.
is the horizontal asymptote.
Right.
It's at y equals -3. So you're going to have a dashed line there at -3.
Yeah.
Might put that in. And then the range is either, it depends on whether the graph shoots down or shoots up to it or somehow comes back. It's either minus infinity to -3 or it's -3 to positive infinity. So we can get that at the end, or if you're comfortable with the transformations, you get it now. So we'll come back to that.
Okay.
You have to plot 2 points. Okay. And I think that's probably the real, real core challenge of this.
Yeah.
So the points that you want to choose, generally 0 is a good one,
Mhm.
because anything to the 0 power
It's just one.
is just 1. But in this one, you have to be careful. It's just the part in parentheses that's to the 0 power. So there's really like a -1 over here.
Yeah.
So it's -1 times 1 minus 3 is -4. So that puts a point kind of right there on the graph. And that does answer our range question, but we'll come back to that.
Mhm.
You have a choice on the second one. If you put 1, you're going to have to deal with fractions. If you go
Yeah.
-1, then you flip it.
Mhm.
Which would you like to do? Which do you think you would do on the test? Would you go 1 or would you try to flip the fraction?
I might just do one.
Okay.
Yeah. Or
So that's -1 times 1/2 to the power of 1 minus 3. This is the 1/2 times -1 is -1/2
Mhm.
minus 3. Make a common denominator. So this becomes 6/2
Mhm.
and then -7/2. So there's your other point, -3.5. So we know that it's about there. So your graph's going to look something like this.
Mhm.
And that tells you that your domain is now this one. Think of it as a bottom to top.
Yeah. Okay.
I'm sorry, for the range,
Right.
bottom to top.
Okay, got it. So big. Okay, got it. Yeah, I'll probably practice a few more of those. Let me see what else. I'll show the screen. Okay, yeah, this one I'm kind of stuck on.
Okay. So coming up there.
Yeah, I see it.
All right. Find the initial population size. So the initial population size is when t equals 0. T equals 0 is times 0 starting point. So you're going to put 0 in to the function 1 plus 5e to the minus 0.3 times 0. The exponent And the e there is 0. So e to the 0 is 1.
Mhm.
So the bottom becomes just 1 plus 5. Is that something you're okay with?
Yeah, okay, yeah.
And then you divide that. So 280, does that work out? Does not.
Mhm.
Let's go, I get it round to the nearest whole number.
And that would be, I would writing this in decimal form.
Is this the nearest whole number?
Yeah.
Surprised didn't work out. Wouldn't have been that hard for them to make one that worked, but
So would that be 47?
let me get my calculator out. Always rounding issues, right? It's like, can't just,
Yeah.
it is 47.
47, yeah.
All right, so after 8 years, t is 8, and you're just going to replace the value of t with 8.
Mhm. Oh, okay, I see it,
That's a little more involved, but
okay, this is okay. When you plug it into the calculator, is it just, or I guess I'm using Alex's calculator, but
yeah, probably a good idea to use their
yeah,
calculator.
yeah. 193. Okay. Okay, I don't really have anything else to work on. I feel like that covered it.
You sure?
Yeah, I'm sure. Yeah.
Okay. All right. Well, let me go ahead and stop the recording here.